Welcome to Lesson 16, Part 2, Applications of the Normal Distribution. Here we'll be doing some more calculational type problems. Remember that the standard normal distribution has a mean of 0 and a standard deviation of 1. We need that format to use the chart to do these problems. All right, first question up. The lifetime of a certain type of car tire is normally distributed. The mean is 40,000 miles with a standard deviation of 5,000. X represents the number of miles that the tire lasts for. We want the probability that a tire lasts more than 47,000 miles. Probability X is greater than 47,000. We need to convert this over to a standard normal distribution, mean 0, standard deviation 1, so that we can look this up on the chart. So we need to do the conversion. So we make the Z substitution, X minus the mean divided by standard deviation. So 47,000 minus the mean of 40,000 divided by 5,000 becomes 7,000 over 5,000, which is 1.40. You want to round Z to 2 decimal places for the chart. That 1.40 is telling us that 47,000 is 1.4 standard deviations above the mean. If Z is negative, we're talking about something lower than the mean. So we want the probability that Z is greater than 1.40. And so that we can get using the chart. Now, the chart gives the area to the left. The chart gives the opposite area probability less than 1.40. So we have to do a subtraction. We're going to get the table value, and then we're going to do 1 minus the table value to get the greater than side. The greater than side is to the right. So we look up 1.40 on this chart here. So we go down in the row here to 1.4, and then we need the second digit to be 0. So we do 0.00 first column, and that's 0.9192. So our probability is 1 minus that, because that's the opposite complementary point of view. So it's 1 minus 0.192, 1 minus 0.919292, which is 0.0808. About 8%. So let's look at this graphically here. We have a standard normal distribution, mean 0, standard deviation 1. The z-score we got was 1.40. And we wanted the greater than side. So we wanted the side to the right. The chart gives us, by default, the chart is giving you the area to the left. That was the table value was 0.9192. We had to do 1 minus that to get the opposite side. The whole thing adds up to 1 whole 100%. So we had to do the subtraction, 1 minus 0.9192. That gave us 0.0808 on the right-hand side. All right, part B, find the probability a tire lasts less than 42,000 miles. So less than is going to be to the left, so we're not going to have to do the subtraction this time. We have to convert it to a z-score. So we're going to do x minus the mean over standard deviation again. X was 42,000 this time. Mean is still 40,000. Standard deviation 5,000. Subtraction. Simplify the numerator first. That's 2,000 over 5,000, which is 0.40. We're going to get this directly from the table. Directly from the table, we're going to look up 0.40, and we're going to use that table value. So looking up 0.40, again, it's the first row 0.4, the first column, and that's 0.6554. Again, we're using the 0.4 row and the 00 column there. So the area to the left directly from the chart, z-score was 0.40. We want the amount to the left. And we can see it's more than half, right? The 0 line is the median, so that splits it 50-50. And we're at a positive 0.40. We have a little more than a half of the area of this bell-shaped graph. And so it's about 65.54%. Find the probability that a tire lasts between 36 and 51,000 miles. So we have to convert both to z-scores here. So it's 36,000 minus 40,000 over 5,000. That's going to be a negative number here. It's below average, below the mean. So it's negative 4,000 over 5,000. That's negative 0.80. Then we convert the 51,000 minus 40,000 over 5,000. 11,000 over 5,000. That's 2.20. So we need the probability that z is between negative 0.80 and 2.20. So we're going to do a subtraction to get the area between. We subtract the value from the right minus the left. So we're going to do a subtraction here of table values. We're going to look up the 2.20, which is 0.9861. And then we're going to look up the negative 0.80, which is 0.21186. So rounded to 0.2119. We subtract those values to get the area in the middle, 0.9861 minus 0.2119, and that's 0.7742. So it's about 77%. All right, part D, find the mileage that cuts off the top 10% of lifetime miles. So this is the opposite situation. The problem is giving us the percentage area probability, and they want to find the X value, the number of miles. So we have to work backwards here. So we're trying to find the cutoff score that cuts off 10% on the right, the top 10%. Now remember, the Z chart is always based on the left, so we need to look from that point of view. If it cuts off the top 10%, there's 90% on the other side. Now I'm writing it as 0.9000 because we're going to look at the body of the table there with these 4 decimal places for the closest thing to 0.9000. So again, we're cutting off the top 10%. That means 10% to the right, 0.10 to the right. So there's 90% to the left, 0.9000. So we look that up in the body of the chart here. So a little bit different setup here. We look in the table for the closest thing to 0.900. And so it's a little bit tricky here because you have the 0.8997 and 9015. So usually in this situation, we just go with the closer one, which is the 8997. We read off the row it's in. It's 1.2. The column is 08. So we're going to use 1.28 for an estimate for the z-score that cuts off the top 10%. So 1.28 was the closest. Now we just have to convert that back to an X score using this formula. So we know Z is X minus the mean over standard deviation. So X is going to be Z times sigma plus the mean. So it's 1.28 from the chart. Standard deviation was 5,000. Mean was 40,000. So it's 1.28 times 5,000 is 6,400 plus 40,000 is 46,400 miles. So 46,400 miles cuts off the top 10%. So that's this graph here. Okay, up next, a little bit of a messier problem. A certain brand of refrigerator has a useful life that is normally distributed with mean 10-year, standard deviation 3 years. The useful lives of these refrigerators are independent. Calculate the probability that the total useful life of two refrigerators randomly selected will exceed 1.9 times the life of a third randomly selected refrigerator. So we have a situation here where we want the total of the first two to exceed 1.9 times the third. So using x and y for the first two and w for the third, we want the probability that x plus y is greater than 1.9 w, which is equivalent to, if we subtract 1.9 w, it's x plus y minus 1.9 w is greater than 0. So we bring the variables to one side, and what we have to do here is compute the mean and standard deviation for this new expression here. So the mean and standard deviation for each of these separately, mean is 10 and standard deviation is 3. So what's the new mean going to be for x plus y minus 1.9 w? Expected value is linear, so it passes through. It's going to be e of x plus e of y minus 1.9 times e of w. So it's 10 plus 10 minus 1.9 times 10, which is 20 minus 19. So it turns out to be a mean of 1 here. Turns out to be 1. Now, remember here, we're given standard deviation, but actually, calculationally here, we want to work with variance. Variance has nicer properties here. So it's the variance that we're going to work with. These are independent random variables. So we can pass through one at a time here. It's variance x plus variance y, and then it's going to be, remember, there's a constant multiplier. It gets squared when you're doing variance. So it's negative 1.9 squared times the variance of w. Each variance is going to be 3 squared. So it's going to be 9 plus 9 plus the negative 1.9 squared is 361 times 9 for a variance of 50.49. So the variance of this new expression is 50.49. Then we convert it back to standard deviation, taking the root of that, it's about 7.11. So this new random variable here has a mean of 1 and a standard deviation of 7.11. And then the goal is to find the probability that this expression is greater than 0. So we have to convert this over to a z-score. So we're going to take that 0 and plug it into x minus mu over sigma. Let me just write that out here. So what's happening here is we were trying to find the probability that x plus y minus 1.9 w is greater than 0. So if I can use a new letter here, let's just call this v. We want the probability that v is greater than 0. So again, the 0 is what we have to convert over. So we're going to convert that over. We're going to plug that into the z-score formula. So 0 here is going to convert over to 0 minus 1 over 7.11, mean and standard deviation. So it's negative 0.14. So what is that representing? That's representing a little bit below the mean, right? 0 is a little lower than 1. It's a little bit lower than 1. It's negative 0.14. So we want the probability that z is greater than negative 0.14. So for a greater than, you have to use the subtraction here. The table always gives you the area to the left. So we're going to look up negative 0.14 and then we're going to subtract. So looking this up here, we're going to go to negative 0.1, negative 0.1, and then finally we see another example here with the 04. And so negative 0.14 is this value here, 0.4443. So that's 0.4443. 1 minus that is 0.5557. So the final answer here is 0.5557, about 55.57% chance of this happening. All right, we'll stop here. There's actually still a little bit more here. So there will be another video here. Again, if there's any questions, please don't hesitate to email or ask in the discussion board.